So I'm the chair for the next hour or so, and I will be introducing Amelia. So let me do that now. Amelia, when you're ready, you can start to share your slides if you like to get those ready. So Amelia Ortiz-Gil is based at the University of Valencia in Spain. She has a PhD in physics, and she's worked previously with Aula del Cel group, and she studied the Lyman alpha forest and the physical properties of galaxy clusters. More recently, she's been working in outreach and particularly in developing inclusive activities for all people. She's the coordinator of a project called The Touch of Universe, and she's developed tactile models of planetary bodies specially designed for the blind. In addition to that, she's currently chair of the IAU, the International Astronomical Union's Working Group on Astronomy for Equity and Inclusion. And last year, 2019, she was awarded the Europlanet Prize for Public Engagement with planetary science. Amelia, the floor is yours.
So thank you, Fraser, for your introduction, and thanks to the organizers for inviting me to give this talk. So in this first slide, you can see the pictures of 6 key scientists and engineers: Leonardo da Vinci, Isaac Newton, John Goodrich, Thomas Edison, Albert Einstein, and Stephen Hawking. Do you know what these guys had in common? Well, they all had some kind of physical or learning disability. But in their case, and luckily for us, this was no deterrent to devote their lives to science. They were lucky to find the means and support that they needed to thrive in science. But I wonder how many others have not been that lucky. How many brilliant geniuses have been lost just because they lacked the material means and support necessary for them to learn and to work? So we lose talent when we do not provide for inclusive measures to embrace the diversity of our students. Of course, it is a moral duty, but I think you all agree with me on that. So my goal in this talk is to stress that besides being a moral duty, it is also a strategic measure for the advancement of science. So including the diverse ones may seem a bit daunting at the beginning, but it is really not that difficult in general. Sometimes it is just a matter of removing unnecessary barriers. Let me show you a very simple example of what I mean. We have here 2 versions of the same graph. The graph shows the evolutions along the years in the number of users of 3 operating systems: Windows, Linux, and Macintosh. And on the x-axis, we have years from 1990 to 2003. And on the y-axis, we have the percentage of users. So the graph on the left uses only color for distinguishing between the different lines corresponding to each of the 3 operating systems. And the choice of these particular colors is highly not colorblind friendly. The left graph, on the other hand, not only uses colorblind friendly colors, but also different kinds of lines, dotted, dashed, and continuous, to distinguish between the different operating systems. I would like to underline that it is not only more colorblind friendly, but it is also better for anyone who can see it. So there are many of these barriers in the learning materials, and many students can feel discouraged when encountering these obstacles. And it can be even worse if, besides the disability, they belong to some racial or cultural minority or underserved social group. So let's get a bit of context. By diversity, I am meaning a variety of ethnic, gender, functional abilities, socioeconomic background, culture, religion, and so on. And on the other hand, inclusion is reached by creating a safe environment in which everybody can speak out and act freely without fear of embarrassment, where they feel valued and belonging, and everybody is equally treated and treated with respect. Of course, in creating this safe environment, teachers and educators play a fundamental role. And it is therefore very important that they are committed to achieving real inclusion in their classroom. It is critical also to embrace the differences, taking advantage of what diversity has to offer, and not just ignore them and pretend that differences do not matter. As I have hinted at the beginning, diversity is key for the scientific success of research teams, whereas it is a research team in a classroom or in a professional lab. And why is that? Well, let's suppose we follow the inquiry-based learning methods in our classroom. Different team members can prefer different approaches to the task in hand and come up with a wider diversity in the questions asked. This, in turn, fosters creativity, success in problem solving and decision making, and all this contributes to the final scientific success. And this is, this is so because interacting with people who are different in terms of functional abilities, culture, gender, ethnicity, and so on, it forces us to communicate with our peers better. And then we have to prepare better our argumentations. We have to anticipate alternative points of view and how we're going to respond to them. And we also will expect that reaching a consensus will take effort. And it will also help us to overcome cultural biases and misunderstandings. So in the end, all this will help the kids to be better prepared to create and put a high value in diverse and fair work environments when they grow up. So this is all very nice and obviously easier said than done. But again, it is not such an impossible task as it might seem. And I am sure that many of you have already put in place some inclusive actions in your classrooms. And so there are different methods that one can use, but I particularly like the universal design for learning because it seems to me quite intuitive and common sense based. So UDL is a framework based on strategies and technologies that support multiple learning modalities. And those include the visual, classical, visual, auditory, kinesthetic, and tactile modalities. So if you take your activities, materials, and resources and apply to them the UDL principles to adapt them, you will end up with a set of materials that will be accessible and even more effective for everybody, regardless of any particular disabilities anyone might have. And the way to do this, according to the UDL, is to remove any kind of barriers, which could be physical, sensorial, affective, or cognitive, to gain access, learning, and participation for students and for everybody in general. So the key is not to focus on the disabled person, trying to change them, but on the disabling environment. And we all have experienced this. If there was a lot of noise in this room, you would not hear me, and you'd be sort of deaf. And I can give you all hearing aid devices, or better, I can remove the source of the noise, and then you will be fine. So the key is multiplicity. You must provide multiple means of representation, provide multiple means for taking action and communicating, and provide multiple means for engagement. We need to provide multiple means of representation. And as different people perceive the information in a different way, we must provide them the contents through different perception channels. For example, Beethoven could not hear the music, but he could read the sheet music and he could feel the vibrations of the sounds being played. We need to provide multiple means for taking action and communicating, because students differ in the ways in which they interact with the learning environment and communicate their thoughts. So we have to give them opportunities for taking action through materials everyone can interact with, and opportunities for communication of what they have learned or about their questions. And for that, we can use software and other means. A good example of this is Professor Hawking. Professor Stephen Hawking was only able to share with us all his knowledge and the results of his beautiful research just because he had the means, he had the possibility to use a computer and a software to communicate with the rest of us. If he hadn't had those facilities, then a person who didn't know him would have thought that he was not able to produce all the theoretical work that he indeed published during his lifetime. Mm-hmm. Students differ in the ways in which they can feel engaged and motivated to learn. And so it's important to use wide choices that reflect the interests of the kids, whether it is sports or technological gadgets or arts or social media. And it is also important to provide them with strategies to deal with new contents or activities so they do not feel discouraged. So an example for a general protocol for the universal design for learning could be this one: teach through all senses, teach to strengths, and provide multiple forms of feedback. It has been shown that the learning process is more effective when contents are provided through different sensorial channels. And it is easier to remember something you have read about, touched, heard, and smelled than something that you just hear or read. So please teach through all senses. And this is also a creativity exercise, but it's really a worth one. Teach to strengths, that is, use the natural abilities and talents as a foundation for learning. Or in other words, you must focus on the abilities of the student and not so much on the disabilities. And finally, to gather a complete picture of the abilities of the students and to check whether the contents are being received correctly, you need to use multiple forms of feedback. Written essays for some students or presentations for other students, communication using some software, computer software for others, and so. So some examples of specific actions you can carry out are, for example, or first of all, check with the students about their special learning needs. And this is key to plan for your lessons. Then activities, materials, and equipment must be physically accessible to and usable by all. And this is involving as many senses as possible, or taking into account some learning disabilities, for example, dyslexia. You should use a variety of means to deliver content, motivate and engage the participants. So you can use a mix of hands-on activities, collaborative learning, inquiry-based learning, educational software, internet-based communications. You have to make sure that the communication methods are accessible to all students, so you can check whether they are learning and how they are in the learning process, and perform group activities for which students have to support one another by placing a high value on their different skills and capacities. And of course, ask for regular feedback from the students so that you learn if you need to adjust the activity. And in that case, you need to have a plan for alternative accommodations for the students whose learning needs are not met by the activity. And well, for example, to get materials under different formats. So I will now briefly describe some of our attempts to organize accessible outreach activities at the Astronomical Observatory where I work at the University of Valencia in Spain. We have been carrying out school visits at the observatory since 2003. And in 2006, we got a request from a special education school, and we developed a new kind of visit, which was tailored to their needs. Together with their teachers, and this is very important, it was the first time we were doing this kind of activity, so we worked really, really close with their teachers and the educators. And together with them, we designed a visit with 2 PowerPoint presentations and some hands-on activities. And one of the presentations was about images of planets and the moons. And these images were reinforced by other sensorial stimuli. For example, when talking about the frozen surface of Jupiter's moon Europa, we were handing to them some balloons filled with cold water. Or when talking about Mars, they were giving some sand to put their hands in to relate with the to the sand dunes on Mars. We also kindled incense sticks when talking about Io and the sulfur atmosphere, sulfur odor that you can feel there, sulfur smell. And then we also developed a presentation with just a series of very relaxing and calming astronomical images with some music for them to relax a bit because they were quite excited after the first talk. As I said, we also did some hands-on activities. They built a curved sundial and constellations with glowing dark stars, which are a favorite for everyone. We launched water rockets, and we also used the inflatable planetarium. It's also a favorite among everyone. Then the International Year of Astronomy came in 2009, and we developed some other activities. One of them was to program an open source software for motor disabilities. So this software is the one that you install in the computer of people who stay all the time on wheelchairs and they cannot move almost at all, like Professor Stephen Hawking. And they use this software to communicate with their carers. And we also introduced some astronomical contents into the software, so they could just browse through these contents while they were at their leisure, while they were resting or having some free time. Mm-hmm. The other project was the Sky at Your Fingertips. This is based on an online astronomy book for the blind by Osservatorio Astronomico di Padova in Italy. They published online this book in 2000, and we asked for the permission to translate it into Spanish. And we also printed a few hard copies of it, and we distributed them among some the libraries of blind associations in Spain and also in South America. We also developed a planetarium show for the visually impaired, the Sky in Your Hands. It consists mainly of two different elements. There was a tactile element, which consisted of tactile hemisphere with constellations embossed on it. And then there was a soundtrack in which there were some sound effects associated to each of the astronomical objects that were explained in the script. And these particular sounds were heard as coming from the place in the dome where that particular constellation was being projected in the dome. So this was a combination of tactile and sound that gave the blind public the whole feeling of the show. They learned the shape of the constellations by touching them on the hemisphere, and they also heard the relative position in the sky by listening to the direction from which they could hear the sound of that particular object. Mm-hmm. The show was shown in different planetaria around the world, premiering in Valencia, but then it went to Porto in Portugal and also to Lisbon. And it's now at the Royal Planetarium in Belgium, mm-hmm, of Brussels in Belgium. Mm-hmm. After that, we decided to develop a 3D tactile model of the moon because the moon is not flat. We realized that as far as we knew, as we were aware of, the only models that were available for blind people to learn about the moon were two-dimensional, were flat. So in fact, during an activity with a 3D model, a blind lady discovered with surprise that the moon was a globe and not a disk. So we got some funding from Europlanet and the Spanish Education Ministry, and we developed our 3D model, which wanted to convey in a tactile way the image of the moon when we look at it from Earth to involve the blind in that very same experience. So we avoided a mere topographical representation, and we enhanced the more peculiar and characteristic features that we can see in the moon's surface. For example, the rays of the craters are embossed. They have some relief. They don't in reality, but they do in our model because crater rays are something really very, very characteristic from craters. So we wanted to show them in the model. It has some other elements to help blind people to explore the model in an autonomous way. There is the polar caps are marked with flat, smooth disks but the north polar cap has a T engraved on it, and the vertical pole of the T is signaling towards the near side of the moon. And then there is a full meridian marking the boundary between the near side and the far side of the moon. So a blind person can know whether he or she is exploring the near side or the far side himself. We also labeled the principal features of the surface with letters in Braille. And we produced a document with the correspondence between each of the Braille letters and the name of the feature in Braille. So again, to let the blind user to autonomously explore the model. So then we realized that we had gathered a few resources to teach or to talk about astronomy to blind publics. And not only blind, I have to say that kids love to touch the tactile moon model. So it's fun for everybody, not just for the blind. And so we put together a kit of accessible astronomy resources. We are using our own resources and some others. We included the materials for the planetarium show and the tactile moon. We included some tactile models of constellations, but this didn't work so well. And we developed a set of activities to be carried with the materials, and we published them in an activity book, which we printed in normal print and Braille. NASA kindly gave us some of the Tactile from Earth to the Universe exhibition prints. And we also included the nice little book, the Little Moon Face book by astronomer Nori Greece, which is also written in Braille, and it's in relief. And of course, we included the soundtrack of the planetarium show and also the guideline to implementing it. And for this project, we got funding from the IAU Office of Astronomy for Development, plus some support and other financial support from a number of other institutions, among them the Galileo Teacher Training Program that you all know. And we distributed this kit to different locations, mainly to developing countries in all the world. And here you can see 3 pictures of some girls handling the materials. Girls' school in Nepal, another in Argentina, and a blind girls' school in India. So after that, we decided, okay, let's go and reach for other planets in our solar system. And we could do that thanks to the help of a friend, Jordi Burguet, who developed for us a software, which he called Amelia and Friends. And that it just creates 3D models from maps. It's really very easy to use, and it's free to download. You are all welcome to download the software and also the models that we have created from the Attach of the Universe website. And we also have our planets featured at the Inspiring Stars exhibition. The Inspiring Stars exhibition, it's an International Astronomical Union traveling exhibition to inspire the younger generation, and it's composed of accessible astronomy resources, and it was organized on occasion of the 100th birthday anniversary of the International Astronomical Union, and it is still being shown around the world. So If you have the chance to ask for the exhibition going to wherever you live, please do ask to the people responsible. I will leave a link afterwards. And so to conclude, teaching using inclusive and accessible methods leads to the inclusion of students with disabilities, as well as making the learning process easier and more engaging for everyone. It helps in keeping and developing the talents that may hang behind a disability. And this will eventually foster scientific excellence in research institutions, and it will contribute to build more diverse, inclusive, and fair working environments for all in astronomy and in science. So I will leave you here with some useful links. The link to our project to develop the 3D tactile models of planets and some other tactile resources. It's a touch of the universe. And there you can find also the link to the software to build your own planetary tactile globes with Mapilia. And the caveat now is to find funds for 3D printing this model, but just developing them it's now easy to do. There you have also the link to the International Astronomical Union's working group on astronomy for equity and inclusion. In our website, you can find other resources, which are accessible resources. And you can also follow our activities and how we and our discussions on our Facebook page, Astro4 Inclusion. Then here you have a link also for the Inspiring Stars exhibition, in case you are interested in learning more about it. And finally, I have included a link to a very interesting NASA document about using the universal design of learning framework applied to space science. Its title is Space is for Everyone, and I highly recommend it to all of you if you are interested in learning more about how to apply UDL to your astronomical lessons. And well, I've been quick and fast, so plenty of time for questions now. Thank you for your attention.
Thank you very much, Amelia. That was very, very inspiring. There's some really, really good resources in there. And yeah, you're opening a lot of doors that are not being opened by other people or for other people. I'm wondering if there are any questions. I haven't seen anything come up just yet. So I guess then it falls to the chairman to ask the first question. We can encourage some people to come and ask questions as well. So after all the good work you've done, this almost sounds like an awful question. What groups are there out there that you still need to target? Which doors are you still not able to break down, as it were?
Oh, wow.
Sorry, that's not a very nice first question, but it was something that I wondered about.
Well, I have the most difficult challenge that we would have nowadays would be to cater for the people who are blind and deaf. Those are really difficult to cater, and you always need some translator. You need definitely the help of one-to-one person to work with them. And the other thing I would like, it's something that we have discussed with Rosa precisely for this meeting, and it is a possibility the accessibility for deaf people. We thought of, I suggested inviting a deaf speaker, but it's difficult with the technology that we have. Within Zoom, for example, it doesn't seem very easy to have closed captioning. Whereas if you have the meeting through Windows, I think it's Windows Meeting, the meeting platform of Windows, they have already developed some closed captioning for the meeting, so a deaf person can follow what is being said. And but reading all the time is also tiresome, so many deaf people like to prefer to have some sign language on the simultaneous sign language. So yeah, it's something that we definitely need to look into carefully for the next era of online meetings. That I think it's just beginning, unfortunately, because I would love to be in Norway these days, as you all.
Yeah. Can I hop in with a question, Fraser? Well, not a question, is a conversation with Amelia.
Rosa, yes. please carry on. Yes.
Amelia, amazing as always, looking at the work you've been doing, and it seems to me like it's something so important, and sometimes not proper importance is being given, or proper, not importance, but proper support. But I remember that when we were together in one of the IAU meetings for the celebration of the 100th anniversary, you were discussing also the role of inclusion in terms of gender, and in terms of, I mean, we had Alan speaking yesterday about social and cultural exclusion. So we're mixing here something that is far bigger than we imagine. So you started your presentation by showing that slide of people we all know very well. But you also mentioned this is one slide that you put together. It's not a million people, it's just a few. And can you just elaborate a little bit, how do you see inclusion taking a broader range rather than only for people with special need? I mean, everyone has a special need. But if you put together someone with some impairment, visual, auditory, or I don't know, all of us have some levels of different autism, dyslexia, or plenty of other things. And if we add to that prejudice, intolerance, racism, it makes it even more difficult. So I wonder, why aren't you receiving millions of dollars to enhance what you're doing? Because it's targeting like, what, half of the population of the world, if not more?
Mm-hmm. Yeah, I think, well, there are still a lot of barriers we have to overcome before we really convince the people who have the funds to employ them into reaching a more diverse spectrum of students, and then allowing a more diverse group of people to enter into the scientific field as professionals. And I think academia is, although many people are talking already about achieving a real equality in the workplace, there are still so many biases that we have, even unconscious biases that we are applying all the time without even being aware of that. So I think we all need to be, in some sense, we all need to be re-educated, because there are many biases that we are not aware of, and maybe we are trying to do something right for a group of people, but then we are excluding another group of people, and we didn't realize that. So I think it's really a work that we all have to do together, and it really needs, we really need to create, how to say, large working groups that will look into these matters, because it's really difficult. And yeah, there are already some things that are being placed, that are being used, like blind peer review for articles or for grants that can help some groups, especially women, to win more grants than if it is not that if their name is on the proposal, for example. But these are just very small steps, and it would be great to have really a large, big plan to proceed in a more, how to say, in a more professional way to do this.
So maybe I can continue to infect you. We, as you know, Global Hands-on Universe continues to grow. We have more and more people joining us, joining hands, and we have very talented professionals working and collaborating with us. And for some time now, we have the Astro 101 course being cooked up. And I think that we don't want to replicate what is out there, because there's hundreds of thousands of amazing good things, but we want to pursue the hands-on universe style, and maybe you will join us in ensuring that, you know, all the inclusive aspects as far as much as possible are there. We know that COVID is not here forever, but I think that this trend of teaching online, especially thinking that you enable reaching out to more people because you're doing it online, as the Global Hands-on Universe conference, and because we are recording so people can watch it later, maybe you will consider joining hands and also bringing more professionals to make sure that we are designing as universal as possible. So this is something that we should not take for granted, that we are doing the right thing without the proper expert on board. And so far we do it on volunteers, so it's slower, but we can do it. And maybe we will find a very good donor, maybe watching us, that will help us in this very amazing mission.
That would be great. Yes, I'd be very happy to help you with that as much as I can. There are many people around there who are really doing wonderful things, like Mirjana Povic is doing great things in Ethiopia and in Africa. Or oh gosh, I'm very bad with names. Okay, there are many people around the globe, or Kumiko Usuda-Sato, she's doing great things, and Lina in Japan. So there are many people you can, I'm sure they will be very happy to help you with Global Hands-on Universe in this next step. So yes, please count with all of us.
Amelia, we have one question and one comment that are related to each other. So I think if I can ask you those. From Johannes says that thanks you for the talk, and says that you have some interesting links to the 3D models, which he's going to try and access. Also on the question and answer from Kok Chung Chin, touched to see the photos of the 3D planetary model for disabilities. Thinks they're wonderful. Was asking if you can share some more information about those. So I don't know if you have any more slides, or you were able to comment further on the 3D models.
Okay, let me share the...
And Kumiko, thanks you for mentioning as well.
Yeah, thank you, Kumiko. Okay. So one thing that it's key in these models, it's that they have been modified on purpose to show just the relevant features, and then we erase or smooth out all other details, so that the models are not too confusing. So that, for example, in the Mars model, you can clearly see the Valles Marineris here and the Olympus Mons here, but you don't get to see much in the middle, because in between, because most of it has been removed in order to give clarity to the model. If you touch one of these tactile models for the first time, you don't want, and this was something we found out in the first tests we carried out, that our moon had too much detail, the very first model of the moon. So we had to erase some of the details in order to have a more clear model for the people who are just touching it and cannot see it. So this is one thing to take into account when developing this kind of models. And the other thing would be that I know it's cheaper if you produce small globes, but then everything is, again, very close together, and the person with visual impairment is not, will not have such a good experience with the model than if it is larger. So I always advise to print at least a 15 centimeters globe in diameter. We usually use a 20 centimeter diameter models. And the very first models we were using were 30 centimeters wide, and they were too large. They were cumbersome, and they were not comfortably manipulated by the users. So we have found that 20 centimeters is about right. It's not too small, so you still have some distance between the important features that you want to enhance in the model, and it's not too large that it is cumbersome to use. So these are the two main things that I would suggest you take into account when you are trying to produce your own tactile models using this software or any other you want to use, of course. Mm-hmm.
Okay, thank you very much for that. I think unless anyone else wants to jump in, Rosa, if you have anything else you want to say, otherwise we're pretty much done on the questions as well. So Amelia, I'll thank you again for attending today and for joining us and for providing this insight into what you do and how it benefits